Today, I'm going to be talking about how we created a URL shortener. Now, it might seem simple, just shortening a URL, but if we actually wanted to deploy this and have this be production ready, it's going to be a lot more complicated. So let's go into a little bit how we made it. So we cover 3 categories, we cover 4: scalability, reliability, observability, and our 4th one is just really good documentation. So what does the architecture actually look like? Here we have our hosted product, and it's a little jumbled at first, but here we have our user front end. Our user front end directs into our load balancer. Now this load balancer splits up the traffic between 2 replicas. It splits it up evenly, and it's using least connection scheduling. And that is saved into our Postgres database as well as our Redis caching. And then we also have an admin dashboard. This we can see all of the metrics we need in order to keep our product running. So in our admin dashboard, we have our containers. So this is everything that is a part of the app that is online. We have a dashboard, the backend specifically for the dashboard to get everything. Our load balancer, we have our database. We have a cron job that constantly checks for heartbeat signals within all of our instances. We have our Redis for caching. We have our replicas of our actual server. We have our user front end as well. So here we can see how much CPU it's taking as well as the memory it's using. And if there are any issues or any traffic that goes through, we can look at our logs. Here we can see the logs, we can see the spikes, we can see any errors that occur, and then we can see the error rate percentage as well as the actual logs that are going in between both replica A and replica B. If we click into the logs, we can see a JSON response of what that log actually is. And here, we can test out the live logs right now. Let's shorten a URL again. Let's just shorten the same URL. Okay. And it gives us this. So let's go to our dashboard. Here, you see we got a post request. Right here for shorten, and you can see all the information is the same. So here we just have our logs, and we can have a lot of filtering. What happens if we actually want to test our system? So here we're testing for virtual users, and we're covering our bronze, silver, and gold tier operations. So quickly, I'll test for 500 users. This test is for 1 minute and 50 seconds, so let's try doing just 1 minute. And let's run this. And as this goes, we'll see the system ramps up to 500 users. We can see all the logs that are happening. We can see the amount of errors as well as the error rate as the time progresses. We have our average latency as everything goes up, the time elapsed, and then our peak latency. So this is the top 5%, just like top 5%, the outliers in our data for our latency. And so 30 seconds have passed, and then 500 active users, only 9 errors. And we can actually analyze these errors back in our logs as well. So if we look at our logs, you can see some 500 errors that are happening. Oh, these ones already happened on a previous time, but part of the same issue. Yeah, and then on top of these logs, so we have our simulated test. We can also look at the telemetry. So something we want to test is the 4 golden signals. We have traffic, latency, errors, saturation. Here we're looking at errors, but here we can also see the latency. We have the different subgroups between our normal and high-end latencies. Everything's 0.1 milliseconds right now for previous runs. Here we have our traffic, and here we have our saturation. And again, all of this is happening in real time. And here we are. And what happens if something actually breaks? You know, I'd have to spam our system with a lot of users to actually break anything, but we can actually just kill some instances on our own. So we have this dashboard that allows us to actually kill one of the Docker containers. So here, let's kill this instance. Here we'll delete it. And so right now we have the current status. It says it's online, but in a second it's gonna label it as exited. Yeah, perfect. And then we have our process that's gonna automatically restart it. So it's gonna take a second, and it's gonna give us a notification saying that it discovered an exited process. Then it's gonna deploy it, and then it's gonna let us know when it's back online. And this is actually gonna trigger a Discord notification. So imagine you're sleeping, it's 3 a.m. You're not gonna know, you need to be notified some way that your server has broken down. So here we got a notification that it's exited. And here in our Discord server, we have our Discord bot Happy. He's actually our AI agent that oversees our entire dashboard. Let us know that our app crashed. Let us know that it's redeploying it, and it let us know that it's back online. And here we can check if we refresh the container or our container information. We can see, oh, it's still deploying, that everything is online. Okay, awesome. Everything is online. And so our standout feature has to be Happy. Here's our AI agent that oversees our entire dashboard. Every single tool that we have available in this dashboard, Happy can also use, as well as being able to send us Discord notifications. So we just ran a test. Let's ask Happy about that test. I just did a load test for around 500 users. Can you analyze the different errors and the compute usage of all the load balancers and instances, and then come up with a report for any bottlenecks that you find? So right now, Happy is doing a search for all the live data, and then it's gonna formulate it into a response, and hopefully it's usable data that we can use to improve our platform. So this is running, and here Happy gave us an analysis report. So we have a lot of requests. We had 33 errors. A lot of them were status 409. So here's some notable log entries. And here the compute of each of our devices at the time that these errors occurred. Let's see, 409 errors indicate conflicts, possibly due to duplicate submissions or resource constraints. Interesting. Dashboard backend and URL shortener. Okay, anyways. So Happy is able to give us a report. That Happy is also able to run tests on his own. Looking at this report now, Happy, can you run your own test? So set up your own number of virtual users, your own number of, your own time constraints, and then try to further identify the issue. So if I tell Happy to run this, what Happy is gonna do is, he set a test for 100 virtual users in a minute, and the test is probably running. Yep. So here we're running 100 virtual users and across a minute. So to summarize, our entire dashboard completes the gold quest for the scalability, reliability, and observability. All our documentation lets the users know, or anybody who wants to develop this, how to use the product, where issues can arise, and what to do when they occur. Thank you so much.